Hi, welcome again. In this video, we'll discuss about motion in one dimension. And in this motion in one dimension, the first topic we are going to discuss is distance and displacement. Let us have a look. Here, this is a distance and displacement. So when you come to that understanding of distance and displacement here, so the first one is distance here. So just as per normal standard definition. So what is the standard definition? Here is the distance definition is the total path length covered by an object during motion. So I'm just trying to highlight this definition here. Look at here, this point. The total path length covered by an object during motion. The total path length. Okay. Now, trying to understand that this same definition, that is distance definition with the displacement. Okay. So most of the students are just have doubts with the distance and displacement. So that's the reason why I'm giving the comparison even before going to explain the details of distance and displacement here. Okay. So what is a displacement? So the displacement is, look at here, the shortest line or the shortest straight line distance between initial and final positions with the direction. Okay. So there are 2 points here. The definition itself has 2 points. The shortest distance between 2 points and also direction, whichever the direction. Okay. So that's a basic thing here. You need to be very mindful about while understanding the distance and displacement. Now let us dive into the concept of distance here. So what is the distance? Okay. So basically the distance is a scalar quantity. It means you can measure the distance. Okay. It's a quantifiable. You can actually use some take some quantity, take some measuring method, and then you can quantify it. The first point. Then apart from this, here you need to understand here the distance, basically it will be either positive or 0. It can never be negative. Why? Is because either that object is in the form of a rest or it will take a motion. So when you take a motion, this quantity is a positive quantity. Or else say when it is at rest, the distance is 0. There is no any change here. Okay. So no change means it will be 0. But it can never be negative. Why it can never be negative is you will be able to compare when we are talking about with the displacement. Okay. Now these are some points here. So it depends upon actual path taken, measure. So in SS system, generally we measure in meters. In CGS system, we measure in this in centimeters. So apart from like this, just try to understand the definition of a displacement here. Very simple one. For example, I'm going to take this a small shape. Some shape here. Okay. So in this shape, assume that there is a body and these are the points A, B, C. There is some quantity. Okay. Some object, say for example, some ball or some tire. Okay. It traveled from point A to point B. Okay. So it traveled from point A to point B. Okay. Then you can say then when it travels from point A to point B. Okay. That's a good one. Then from here again, it traveled from here to here. Here to here. Point A to point C. Okay. Now what you can say, a object moved from point A to point B and from point B to point C. An object moved from point A to point B and then from point B to point C. Okay. Now if you calculate what is the distance, is the distance, for example, this is something length L and this is something length L. So this will be here length L and length L. So the total distance will be 2 times of length. 2 times of length. But if you look at the displacement definition, the shortest straight line distance between initial and final positions with a direction. The shortest straight line distance. So if you look at here, what is the shortest straight line distance? The shortest straight line distance is from this point to this point. Okay. So if we consider from this point A to B and B to C, it will be very lengthy one. But instead, in this triangle, assume that this is an equilateral triangle, and then all the lengths are same. Okay, that is the length, this is the length, and this is the same length. Then, if this becomes a distance, then the displacement becomes A to C. So A to C is L. So the value is L itself, nothing more. Okay. So that's the way we calculate the displacement. So have a simple understanding between the distance and displacement here. So distance means you will be calculating all the length, whereas the displacement is from initial position. This is the initial position and this is the final position. From initial position to final position, what is the length? That you the shortest straight line distance, and also you need to take this direction also into picture from here to initial to final. So from initial is the start point and the final is the finish point. Okay, so that direction also you need to take into account. So this is the understanding of the distance and displacement and the difference between distance and displacement. Now try to understand this displacement here. The displacement, because of this direction, this displacement becomes a vector quantity. And so for example, if you look at the formulas and all here, so the change in the respective length is final length minus initial. Okay, so that these are common things and all here. And the main characteristic difference between the distance and displacement is the displacement can be positive, negative, zero. Why it can be negative or zero is sometimes here, if you look at here, for example, in the same case, if the object which moved from A to B, B to C, and again it returns to C to A to B, B to C, and C to A, then that for this the distance is 3 times of L, whereas the displacement becomes 0. Why? Because the initial position and the final position are same in this case. So initial position is same point, final position is also same point, so hence this becomes 0. Okay, so that's why we need to see that here whenever we are calculating the displacement. So it can be, we should be careful about the values. Okay, but one point is very clear: the displacement can be 0 or positive, whereas the displacement is based upon the positions, initial position and final position you need to calculate, and also direction also you need to take into an account. So that's the reason why here it can be positive, negative, or 0. And so it is an independent path and depends upon only initial and final position. These are normal things and all here, but when you look at this measurements in meters, so this is also as per SI units, it's measured in meters, and normally if it is a CGS system, it is measured in centimeter system. Now because of this small variation, okay, it's better to understand the distance and displacement in a differentiation manner. What is the difference between this and that? So if you look at here, the distance is nature itself is a scalar quantity. Distance does not have any direction, so it cannot carry a vector quantity, whereas the displacement is a vector quantity, so hence it includes both scalar and a vector. So whenever you are explaining the representing the displacement, you must represent with the direction, or else you have to, so magnitude is already represented. So, but the direction is a mandatory concept here. Okay, whereas the dependence here, both are path independent. This is a path dependent and that is a path independent. Okay, and so displacement is you have to trace out all the paths. So how much, whichever the path, so initially and finally So from initial point to the final point, how many paths it took place? So all the path you need to carry out. Whereas the displacement is a path independent. Find out the initial point, find out the final point, draw a straight line, find the distance, and then what is the difference between this, then the straight line length, and then make a vector from initial to final, and that's the way you calculate. That's the reason why it becomes a path independent here. Then this distance is basically always it's greater than 0, okay, or else it is 0. Whereas this displacement will be passed to -0 quantity. So, and the main point here you have to understand, the distance is always greater than or equal to displacement. So hence the distance is basically a more quantity, or else it is 0. Whereas the displacement here is always less than the distance. Okay, so this is very easy way of remembering the point. Okay, so some examples on all here. So like this, I'm thinking about a point. So if you look at the mathematical formulation, for a one dimension, we can say the displacement is final position minus initial position. Okay, whereas the distance is basically sum of all the intervals of that, how much distance it has traveled. And for a two-dimensional variations and all, two-dimensional motions and all, you have to take a positional vector into picture. So same thing, same formula. So final positional vector minus initial positional vector, and for example distance and all, this normal things and all you can take into picture here. And sometimes there will be something called as a special case. What is a special case is for this is one simple example here. Here this is one, just I'm going to try to explain a simple point here. For example, there is a point a object moving from point A to point B. Okay, so if it goes from this point in a curve shape, okay, and if it goes like this, then what is the distance? This is a very frequently asked problem, distance and displacement. What is the distance and what is the displacement? Okay, most frequently previous year asked the question. The distance here, we know that this is a circular, this is basically a perimeter of a circle, right? So here half of the perimeter you have traveled. So what is the total perimeter of a circle? 2 pi r. The perimeter of circle is 2 pi r, and this is half of the perimeter. So hence what would happen here? The distance between A to B will be pi r. Okay, sometimes we can write like this pi d. Okay, and this becomes a pi d by 2, some small way. Okay, some idea. And here this is basically the distance. Okay, now what about the displacement? The displacement is, according to definition, the shortest distance between the initial position minus final position, considering the direction. So now we know that this is a half perimeter. So this point A to point B, it passes through the center of the circle. So this will be the radius r and this will be the radius r. So hence the displacement here is radius plus radius. So hence this becomes a 2r. So the displacement here is from A to B is 2r, whereas this one is pi r. So that's basically the one of the special case that you need to mind about. Okay, it's basically when these are some examples, we'll look at some problems. This one variety. Okay, then in a rectilinear motion. So these are all some examples. Please have a look at those points. And parabolic. So that is the thing. Okay, basically that is a basic idea about the distance and displacement. So if it is a distance, then you need to take that all the paths how much of all the paths, and then you have to accumulate all the paths, and then you have to add it up and sum it up to find out the total distance. If it is a displacement, find out the initial position, find out the final position, and then draw a straight line, and then what is, and also know the distance, know the direction also here, and then when you calculate that the length of the straight line from initial position to final position, so that is the displacement. So that's the basic difference between distance and displacement. And also you understood the meaning of the distance and displacement. I hope you understood this lecture. We'll meet again. Thank you.